Hi, welcome to my channel. I've decided to start another project for my engine, and this time it's a steam brake. Now, I did have a steam brake on my previous Loco and I was really happy with it, and it's worked very well and was very reliable, and it did actually work and you could control it. So I thought I'll actually have a go at making another one. Now this design, it can be seen, it appeared in Engineering in Miniature many years ago, the very early issues of Engineering in Miniature, and it was a design by a gentleman called Ross Harrison, and he was building I think it's either a 5-inch gauge or a 3.5-inch gauge tank engine. I can't remember exactly. I think it could be 5-inch gauge, and he described this steam brake, and I thought, well, it looks okay, I'll give that a go, and it did work, as I say. So I'm going to make it again. It's a fairly simple design. There's nothing really complicated. It's straightforward, but as I say, I just doubled it up, and I'm going to have a go at making this. I say it's a lot of years since I did make one for my previous engine, but I'm going to have a go with it, and that's my next project. And then what I shall be doing after that is to make the actual brake system, the brackets for holding the steam cylinder on the side of the frames. Now previously, as I mentioned in the previous Loco, I had a brake cylinder there, but it was jacketed. I had a jacket around the outside. I had a small steam feed to it, and it kept it hot. And also underneath there was a small drain which just leaked out any water from the jacket or steam once it got hot. And that, I think that made it reliable, because it was constantly kept hot and there was no condensation. So I'm going to do the same again, and it's a simple cylinder, nothing fancy, and that'll be the second part of my project. So that's the next job.
Well, here's a closer view of the drawing, and showing you the details of the brake. And as you can see, it's a simple brake, and it's quite straightforward. Sorry about the flickering on the screen. It's due to these LED lights, and it's probably my camera settings are not set right. I'll have to have another look into this. I've had problems with this before. I've never been able to sort it out. But there you can see a little bit more detail. Now I'm just drilling out the end of this valve body to tap it, and this is so as to enable a small adapter which the copper pipe is attached, and this is the exhaust for the steam brake. Now I've previously drilled and reamed this valve body at 3/8 of an inch. Now I'm just going to tap it out now after drilling that valve body. And this tap's squeaking a bit. I think it could do with a little bit of WD-40 on it. But it's only a short thread, so it'll be okay. I just now need to put the tap wrench on. It's just a short distance to tap. Normally I can tap through with using the tailstock and tapping the chuck, but it would look a bit stiff. I think the tap could do with sharpening. I think that could be another tool and cutter grinding project in the future, sharpening taps. Well, after drilling and reaming and tapping the body of the brake valve, I'm drilling straight through now. Now the top portion will have the oil reservoir, and the one below will have the connection, the threaded connection, which will take the copper pipe down to the brake cylinder. Now after drilling through, what I did then was to mill a small flat on the top portion where the the oil reservoir will fit, and this will ensure that it sits squarely on top of the valve body, and it will make it easier then to silver solder it in place. Now I've drilled right through this valve body, because these ports need to be in line, so that when the valve is in position, steam from the steam fountain passes through these ports and down into the brake cylinder. Well, I've now put a small slot drill in place of the drill, and I'm just going to mill a small recess flat, so that the oil reservoir will sit squarely on top of this body when I silver soldered it, and it doesn't tilt over. I suppose I could use a small peg on the oil reservoir, but I think this is a better and neater way. Now this is how I originally brazed it together, silver soldered it together, and I wasn't right happy with it. The bracket there for the lever, there wasn't enough protruding outwards, and it was clumsy. And after I'd milled it like I am doing here, I decided that it'll all have to come off. So I took the top block off and made a small extension and slotted that and silver soldered that in place using high temperature silver solder and some screws. And then I was hoping that when the oil box was going to be silver soldered, on the small block on the side would drop off, because that was not needed. So what I'm doing here now is slotting out the extension block which I made out. As I say, I canned the previous one, and this slot is for the lever, actuating lever, which moves the valve in and out of the valve body. It's just a small piece of brass square rail, and I'm just milling it out 1/8 of an inch. Although to look at that cutter going around, you'd think it was going around very slow. I can assure you, it's whipping round over 1,000 RPM. Must be just this strobe effect again with the camera. But after I'd milled this, I attached it to the body with some screws, and then silver soldered it with high temperature silver solder, and that was a lot better than the previous one. There were more overhang with this, which allowed the lever to swing a lot easier. Now, just milling out the 8th slot in the lever for to activate the valve in and out of the valve body. A small pin rides in the centre of this slot, and it enables it to swing backwards and forwards. If you didn't have this, it wouldn't work right well. I'm just going to turn the handle, which is attached to the main lever. You'll silver solder that on later on. It's easy to make this way. Now I'm going to silver solder this oil reservoir using easy flow number 2 to the valve body. Hopefully everything should stop where it is. The lever assembly, that's been silver soldered with high temperature silver solder also, but the block on the side, that was soldered with easy flow, so I'm hoping that's going to drop off. And as I say, it's not needed. It was a mistake with that. Now I've got everything set on these fire bricks, makes it easier, and my vice is actually set a lot higher than normal. It's not at the standard elbow level, which you should have really, but I've done quite a few jobs for a certain company, a small company over the years, and it entails almost high level filing, drilling and other things, and I've just left it as it is. And if I need to do any work at normal level, I just stand on my small duck board, and I've just left it high like this. It does have its advantages, especially doing a job like this where you can get a better view almost at eye level. Well, everything was going on okay. The temperature was getting there, and I was hoping that the block would just drop off after I got the silver solder around the oil box, and that worked out okay. It did drop off, and of course the whole lot dropped off onto the floor and made a nice impression in my rubber mat, but fortunately everything else was okay and no come apart. Now this is showing more or less the assembly all finished. There's just the actual valve itself to be drilled now for the ports, and I'm going to use the actual body as a jig and then just spot through, and then that'll complete the valve. There's just a groove to put part way on, which acts as a piston and seal, and I shall use graffited yarn for that, like I've always done. And this just slots into this handle where I've milled it out, and the pin goes through there, and it allows it to swing in and out. This is showing milling out the stainless steel valve with the slitting saw which I had it, and it was just the right thickness. All I did was engage the power feed and let the cutter do its job. It did without any bother. Didn't take long, and it produced a nice clean slot there. It's certainly better than having to file it out. Now I've spotted through, and I'm going to drill now down into the valve body. Now this is for the steam exhaust. I've already drilled through the steam inlet behind, and that's drilled completely through so as to connect with the steam from the fountain down into the brake cylinder. Oops, I forgot to tighten down the vice. Now I've spotted through, and I'm going to drill now down into the valve body. Now this is for the steam exhaust. I've already drilled through the steam inlet behind, and that's drilled completely through so as to connect with the steam from the fountain down into the brake cylinder. Well, I'm now just drilling the end of the valve to make contact with the exhaust port there. It just needed to go a little bit deeper. Now making the coupling for the exhaust. Now this screws into the end of the valve body. Then there's a copper pipe attached to the end of this, which goes to exhaust. It's just a simple drilling and tapping, nothing special. I'll just put the die on the front and screw put that, and then what I'll do, I'll machine the rear of the part it off. I'll machine the rear, I should say, to the size for the die to go on. Then I'll just I'll just part it off, turn it around, hold it in the chuck and put the die on, and that should do the job. Nothing special, it doesn't have to be super accurate, it's just a coupling. So I find this the quickest way to do it, really. Not everybody's method, but I've used it quite a few times and it does save a little bit of time. I'll countersink it for the olive which goes on the end of the copper pipe, and that completes that job. And that's the connector finished.
Well, this is the brake valve more or less finished now. That's the adapter on the front there. There's the cap which needs replacing. I'm not happy with that. Should be a different style. There's the inlet, steam inlet from the steam fountain. This is the steam to the brake cylinder. But that's the job more or less finished. There is just now the brake cylinder itself to be machined up and finished off, along with the mounting brackets, so I can mount the cylinder on the side of the frames, and then all the pipe work will have to be sorted out. I shall test it under air pressure first, and then we'll see how we go from there. So that'll be the next video, the steam cylinder.
For the steam brake cylinder, I'm using this piece of bronze which I've had going about for quite some time now on the bench. I'm just boring it out to 1.1/8, and that's the size which I used on the previous Loco with this same design of steam brake. I'm just measuring the bore now with my old-fashioned verniers. I still prefer these, there's more feel to them than the digital ones. Only trouble is you need a magnifying glass to read the size of the numbers. I still use digital. I've had these a while now and they're quite good, very useful. But I still prefer my my old-fashioned verniers. Just turning down the OD. What I shall do then is just turn down the centre part on the bush, which will leave two flanges at either end, and then I'll reduce these flanges to make locating diameter for the cover I'm going to put on the steam brake. Well, that's steam jacket. I'm just, as I say, thinning down the centre part. The reason for this is to make it get heated up quicker. If you've got a big great bulky piece of metal there, it's going to take a while to warm up and you're going to get condensation. So this is going to be heated with a steam jacket. Now when I've got this thinned down to the correct diameter, I'll be silver soldering two bit pins on either side, and these will be silver soldered. This will enable the steam brake cylinder to pivot to its mounting, and it's fixed at the side of the frames. That round disc on the front of the cylinder there, it's just a piece of brass, round piece of brass with a centre hole in. I put that on just to steady the cylinder. I don't want anything flying out of the fuel. Just now facing down the front flange of the cylinder with the correct across both flanges. Both these flanges are 2 inches in diameter. Now, unfortunately, I don't have any bar large enough to make the end covers for the cylinder, so I'm using these pieces of square brass which I've cut from some sheet I have. Also, I've rolled up a piece of copper which is going to form part of the jacket for this cylinder, which will have a small steam leak fitted to it, so it keeps it hot. That's one thing I used before, and it was very successful. So I need now to just put these in the forge or machine them. Now, as you can see, they're marked out as shown previously. I've got one in the forge or chuck now. I'm going to machine it down. This is for the front cylinder cover, nothing special. It'll just locate into the cylinder with a small register. Now the rear cylinder cover, that will need a small boss, and be like a small stuffing box. It doesn't do anything really, it just guides the piston rod, it keeps it in place, because there's no steam behind the cylinder. It's a single acting cylinder, is this, and the steam's only admitted onto the front of the piston. But, it's not thick enough, as I say, the material, so I'll need to make a small boss and silver solder it to the rear. It's just a matter now of machining down and forming a register, and that'll do for the front cylinder cover. Now the trouble is with these square pieces I've machined up, that one of them wasn't thick enough to include a small boss for the stuffing box at the rear of the brake cylinder, so I've raised the piece on, and now I'm just machining the cover up. I've got the register machine. I'll turn that round and machine the stuffing box. It's not really important in the stuffing box because there's nothing going to be packed there, because there'll be no steam behind the piston. Because the piston's only single acting and there'll be no steam behind, so you don't really need any packing. It's just mainly to support the piston rod in line. I've turned it round now and holding by the register and just turning up the stuffing box. A straightforward job now. this is just a quick general view of the bits and pieces. This is before I'm actually finished off the cylinder covers, especially the one with the boss. The cylinder's mounted on two steel brackets here, which will be bolted to the engine frame by a piece of flat steel. Two pivots there, which I've got to silver solder yet. And I need a piece of flat steel to finish off this bracket, but I haven't got any suitable. So I'm going to have to cut a piece off in the miller using the slitting saw. So that's the next job now.